Everyone to our M.Dot Center webinar series. Today we have Dr. Amir Rahmani, a professor of nursing and computer science at the University of California, Irvine, where he also holds the Samueli Endowed Chair of Integrative Health. He serves as the co-director of the UCI Institute for Future Health and leads the multidisciplinary health sci-tech group at UCI. And Amir, thank you so much for joining us today. I'll let you get started with your presentation.
Absolutely. Thank you so much for having me. I'm really excited to be here. And thank you for the introduction. So as you can see already from the title of my talk, I'm trying to cover several concepts, and I'd like to start from notion of sensing and remote sensing with wearables and mobile data, which is, of course, one of the main focuses of the M.Dot Center. And then gradually I'll show how that can bring personalization and how we can leverage that personalization when it comes to conversational, for example, AI agents or health agents for interventions or other purposes. So let me start with something that in our center, UCI Institute for Future Health, which is a campus-wide ORU, we really focus on. Our focus at our center is really about living labs. Of course, we don't consider that as a replacement for controlled settings, but it's a powerful alternative for traditional, lab controlled settings. And there are many reasons to that I believe many folks on the call will acknowledge. The fact that you can bring user-centered co-creation. In other words, bringing stakeholders and community members to the picture and have a rapid iteration of, for example, designs, interventions, and evaluations of those, learning from them and kind of improving in an iterative way to really reach that level of high engagement and bringing also and considering many complexities of real world. Which of course are absent when we invite participants to our controlled settings, which helps with validity, transferability, and so on. But and many study designs that are pioneered by M.Dot Center and many PIs in this center are very in line with this notion. Like for instance, using smart designs, trying to understand in real world settings what works for whom and trying to optimize those interventions based on the response from the intervention and also kind of bringing gradually the notion of even personalization to the picture. But one key component or requirement for really conducting studies in real world settings is access to data. This is a paper by my colleague and the other co-director of our center, Professor Ramesh Jain, where he talks about how and why the lifeblood of health and living lab research is data, because we need data not only to understand what is happening, but also why something is happening. So the notion of context becomes so important. Not only to understand things, but also to design and optimize interventions, because context and many other factors are really critical. But thanks to especially the wearable and sensor technology, portable devices, smart home devices, these days it's not really anymore a dream to kind of collect continuous data from individuals, and there are hundreds or if not more than that sensors out there to help us understand different physiology, psychophysiology, context, behavior. I've listed some of them that we have used in our research or we have studied their feasibility, starting from like Garmin or Samsung watches all the way to like devices to understand, for example, cerebral blood flow or our continuous blood pressure and so on. But if I want to show the actual power of these devices to understand their effect in real-world studies, I would like to start talking about one of the research that we completed at at UCI, which was a grant from NSF, Smart and Connected Communities grant, where we worked with community organizations in Southern California, pregnant mothers who serve pregnant mothers to, especially underserved pregnant mothers, to help them be more physically active and also manage their stress and meet the ACOG guidelines on physical activity and so on. So I'm not going to talk about the intervention part of it, but just showing the power of data, even when you have small sample size, but a very deep longitudinal study. In this study, which was conducted a few years ago, we gave participants a Samsung watch. We wrote a custom app for it at that time to retrieve raw PPG signals and other signals like accelerometer. We also gave them smart ring and designed an app for both subjective data capture as well as interventions. But I would like to just show you one of the powers when it comes to sensing of such data. As part of some of the studies that we do in maternity care, this is, for example, one of the cohorts that we studied in our projects, and we had about 60 pregnant mothers, like 2 dropouts, so 58 at the end, and we followed. So we use the same technology like Samsung watch and so on, and having raw signals out of it. So we followed up with these pregnant mothers for about we monitored them for almost like 9 to 10 months, second, third trimester, and postpartum. And we had like every few milliseconds, or for every few tens of milliseconds, about 50 milliseconds, we had data. See, it's a 20 hertz sampling rate from this watch. And we end up, even with the small population, having like millions of samples. And unfortunately, some of these pregnant mothers ended up having preterm birth. And one of the things that objective of study was whether we can stratify the risk of preterm birth in this, during pregnancy. Of course, our sample size was small, so more like a pilot project, but we still happen to have a lot of data. So what we did, we started building simple anomaly detection models. This is a very simple autoencoder, a deep learning autoencoder, which tries to kind of reconstruct the data of healthy subjects, or in this scenario, term pregnancy. And if then preterm data is fed to it, it gives you like a high error, if you will. And we only started with just variables related to heart rate and heart rate variability. Didn't even include many other variables that could be included, just to look at the feasibility. And our actual research showed that we can stratify the risk or preterm birth, or kind of predict the risk of preterm birth with an accuracy of about 80%, 79%, already at the end of second trimester by looking at some of these HRV features that were extracted from the PPG, like this is the HR, actually, the AVNN, RMSST, and so on. Of course, the full list is in the paper, but imagine if we had rather than 60 people, like maybe a few thousand people. Powerful continuous data is really important, especially when it comes to building models and so on. So that's just one example. Another example, a project we finished also a few years ago was on, now how to not only try to do sensing, multimodal from wearable and portable devices, but also from smartphone sensing, try to build models for loneliness detection, and then how we can, in college students, and how we can also use that data we collect to build models that can trigger a just-in-time intervention that was designed by one of my clinical psychologist colleagues, such Professor Jessica Borelli, relational savoring intervention to help with loneliness. Very complicated, at that time at least, one of the most complicated systems, and we designed and research designs that we actually performed. And the idea was, as I said, trying to understand and find those acute loneliness zones and send a just-in-time intervention at that time. So it was a multi-phase, and now we're getting more towards the personalization part, where we need to actually understand each participant, because loneliness is highly subjective. It manifests itself differently in different individuals. So what we did in this experiment, the first few weeks, we just observed all the participants, both control and intervention, and send them EMAs throughout the day, and collected that multimodal data that I mentioned. Ring, watch, smartphone sensing, their location, their call logs, their app usage, even how many times they lock or unlock their phones, anything that we could sense from the phone. Then at the end of this baseline, we built models to see whether we can objectively detect loneliness. We had a ground truth in this scenario, EMAs, and wanted to see if we can even do that. And then there, of course, the phase two was dependent on it, because then we used that model for the intervention group to trigger that relational savoring exercise. And of course, we had also follow-up at the end, but mostly this was the part that the model was deployed in the loop in real time to trigger something. First, as I mentioned, we used the setting, our platform, and certain devices to capture this multimodal, multimedia kind of information. We, of course, abstracted many information like location, for instance, abstracting to things like a dorm, a gym, or a school, class, those kind of abstract locations because of privacy reasons, rather than really storing or sending actual coordinates to the server. And the results of being able to predict or detect, if you will, objectively loneliness was kind of successful to some extent. So we could actually detect that by almost 82%, whether someone feels lonely at that time or not. But something that was not very successful at the end was the part that we tried to kind of intervene. As we, or many of you have faced the same problem, the adherence or the response to those push notifications, even though the accuracy oftentimes was correct, at least 4 out of 5, the responses and the completion of the intervention wasn't really high rate. Of course, we understood after that there are many reasons were behind it. The duration was long, and so on. But something I wanted to share, because these are some lessons that we learned, is that the participants found some benefits, like, it helped them to force themselves to think positively, so the reflection with the moments in the past and present helped them. But we ended up having also many UX barriers or HCI components that needed to be more carefully considered for the next step. As I said, heavy cognitive load for the serving protocol and all of those things, glitches that we have at that time, and so on. So, and also the timing. You see, some sets that like I receive a text in the middle of, or notification they meant in the middle of a class, and so on. So that's why even though the first phase was kind of satisfactory, the second phase, the intervention, didn't show us or give us like a statistically significant change in loneliness mitigation. The change was kind of the same as the control, or more or less the control group. But several lessons that we learned. One is, of course, that the detection window shouldn't be considered necessarily as a delivery window, because there are a lot of other things that needs to be considered. And I know in the M.Dot Center, many of the leadership are researching on researching those aspects, the human aspects, how to optimize that, maybe using reinforcement learning or many other techniques. But that's also was kind of confirmed again in this study. But another interesting thing that we observed, which is closer to the focus of this presentation, is the personalization aspect. In this scenario, because we had access to a baseline of each individual, so we used that data. It wasn't like leave subject out type of modeling. We used the personal data that we used to observe each individual to fine tune and build a unique model for each individual. And you see when you analyze each model, for example, participant 8 versus participant 10, in this just as an example, it actually loneliness manifests itself totally differently in different participants. For example, this participant is more like deeply, I would say, physiological. We notice a lot of changes in their heart rate variability and physiology and so on, versus this one was deeply behavioral. The amount of time this person actually spent in entertainment apps, which in our scenario, in our categorization, was like apps like Netflix, Amazon Prime, and those kind of entertainment apps or communications. Those were much more predictive than many other parameters. These are the top 10, if you will, for different individuals, which again shows the fact that personalization is important, and one size fits all cannot really help, and otherwise we can have very poor even accuracy for detection. We have used the same kind of notions and concepts in different studies. Another study we just finished was an NIA on stress reduction using wearable and technology, and also home visitation program with my colleague, Professor Jungal Lee at UCI. This was for dementia family caregivers and to help them better manage their emotions, and also providing educations on caregiving and so on. And we observed technology can play a good role to help us understand, for example, this intervention had statistically significant results in different populations. These are all underserved and mostly immigrants population, Latino, Vietnamese, Korean, and the intervention actually over time, this is the stress derived from heart rate variability over the course of the intervention, and also this is one parameter from sleep, how many times they woke up, or the awake duration, minutes actually, the minutes that they were awake. And we had improvements on these two statistical significant, plus so statistical significant self-reported outcomes, self-efficacy, depression, burden, and so on. But another interesting thing was that even both elderly and their family caregivers, the majority of which were actually whom were elderly too, because a wife or husband was a caregiver oftentimes, the feasibility and / wear time of these devices, smartwatch and ring, was kind of also quite, I would say, good. Maybe more than 18 hours for the smartwatch, and also the rings almost the same range, showing that people wear these devices even for an extended period of time, weeks or months. So that's not the problem, but of course, there are a lot of other considerations. Well, as part of, we, I guess, gave you 3 examples, but we ran in our center tens of similar projects. And one thing that we noticed that at the middle of these studies, that we are reinventing the wheel for each and every study, because most of these studies needed the same sort of, these mHealth studies needed the same sort of technology, more devices or notifications and so on for, building this closed loop, like a researcher dashboard to manage it and track adherence and so on. That's when we started building a platform a few years ago. This is a paper we published about in 2023. We called it ZotCare. And the idea of ZotCare was to build a kind of flexible and reconfigurable platform for mobile health studies so that with almost no code or zero coding, you can design your interventions connected to your devices, add notifications or reminders, and run studies in real world settings for mobile health. We had some good success with that. Many projects were completed using ZotCare, which is more an academic platform, but recently the UCI Bill Applied Innovation or Tech Transfer Unit in 2024, not that recently, about 2 years ago, it actually supported us to turn it into a platform and service that is now available to everyone outside even our center. So if you're interested in using that, please feel free to reach the website. You'll see how you can connect different devices that we have integrated, access to raw signals, because we have partnership with these companies and get raw signals. You can design your multimedia surveys or EMAs, and you can also have access to a small kind of studio to design intervention, bring videos, images, and trigger them not only based on time, but also based on events. For example, sending an intervention only when a sensor is, for example, out of the range or overshoots, like maybe sending an intervention in the mornings following a poor sleep quality detected by Oura Ring. And you can also look at adherence and many other things in real time and download raw signals. And the platform is, by the way, HIPAA compliant. But more or less, this was the sensing part now and personalization. But I think we can gradually go towards the conversational piece. How agentic AI can leverage all this data coming from wearables, portable devices, health data, and making even the intervention parts more interactive. And about 2 years ago, not 2 years ago, actually, I should say 3 years ago, because in 2023, we started working also on the notion of conversational health agents, or CHA, or CHA, in other words, at our center. And our argument or our claim at that time was that because at that time LLMs were very powerful, but agents still were not known enough. So we started championing the idea of health agents that need to really go beyond the pre-trained standard LLMs, the fact that they can communicate with the external world and they can plan and they can reason and bring external knowledge to make the communications or responses more grounded. They can bring data to bring personalization and many other things, even integrate with external models. And around that time, we even released the very first implementation of our platform, it's an open source platform called openCHA. And I would say we were among the very first groups at that time to really kind of championing this idea and even releasing an open source platform called openCHA to build conversational health agents or CHAs. The main philosophy behind openCHA is the fact that you have a main orchestrator, and an orchestrator at least has two LLMs in it, if not more. It uses one LLM for mostly interaction, but the other LLM, which is the brain, does the planning and understanding and interacting with external sources, tools, and so on. And external sources, we defined the most three important ones are a source of knowledge. For example, you connect your agent to NIH UMLS or knowledge graph, or connect it to a food KG by IBM, or you connect it to NutritionX, external curated source of knowledge, and you can connect it to the external data, like your health data, right? Your EHR. And you can also connect it to external models. Maybe you already have a nice validated deep learning model, for instance, to detect arrhythmia, or even FDA approved one. So tons of validated, clinically approved models out there that you can use rather than just dumping all of your raw data to an LLM to try to use a generative model to do it. You can use a deterministic model that you already validated, but you can connect it to your agent. So that is still the philosophy behind openCHA. And the brain follows this loop of, okay, it perceives, it tries to understand each query and whether it needs, each different part of it needs to call and bring external resources. So it transforms that into like more structured data for the LLM. It thinks and plan, multi-step planning, and then it responds back when everything is consolidated and invokes external APIs and so on. We have conducted and completed many workshops and hackathons with openCHA. The reason I mentioned that because we have recorded all of those. We had collaborations with NVIDIA and other Stanford in the Bay Area. We had another one last year at UCLA BSN workshop and bootcamp. They are all recorded and are available in the website along with the source code of openCHA. You can go to openCHA.com and access everything. I want to show you maybe a quick demo of using in openCHA in one of our papers for food and nutrition recommendations. In this demo, actually, openCHA communicates with Centralive platform to bring some, I think, it's an Oura Ring data and some other food logs, and tries to give recommendations on food and nutrition. I can first play the video, and then I'll talk about a little bit behind the scene how it does what it does. But let me switch to my browser. Yeah, this is the website, as I said, openCHA.com with GitHub and all the trainings and everything, and some demos you can also watch later. Let me play this, and hopefully, please let me know if the audio is not doesn't come through.
Sorry, Amir, I don't think we're getting the audio here.
Oh, you're not? Sorry. Then let me, I think perhaps I need to reshare. Stop sharing. Yeah, I need to turn on this setting. Hopefully this time it works.
In this video, we demonstrate an example of personalized food recommendations on openCHA. We first select the tasks that openCHA can perform to generate the response. We select the task to interact with users' food data and health outcomes collected from external wearable devices, and one task utilizing causal inference algorithms to estimate nutrition effects. Then we take two tasks retrieving food nutrition content relevant to the user's query and requesting additional information from the user. Let's start by asking the agent to show my personal nutrition effects on a specific health outcome, such as deep sleep.
So in this demo, which is based on real data, it's not synthetic data, this agent uses N of 1, deep N of 1 data of one individual for about 3 years. This person wore an Oura Ring every night, almost highly adherent, blocked the food every day, every meal. I wish all of our participants were that adherent. Of course, it never happens, but a very deep N of 1 data of food logs, even scale was used, blood pressure and Oura Ring, so sleep, we have access to sleep and so on. So now this person asks, okay, how can I improve my deep sleep quality with nutrition? So the agent now analyzes the the prompt, it understands, okay, this person is asking personal questions, my personal nutrition. So it now needs to go and retrieve some personal data and do some planning. The person is not asking in general how human beings or men or some sort of population questions can help their deep sleep. It's a personal question.
To do this, openCHA will collect data from a food log and deep sleep information tracked by a wearable device, subsequently estimating the causal effects of nutrition on deep sleep. The response will reveal the nutrition effects on deep sleep, with values indicating the estimated average treatment effects of the nutrients per unit. We can also ask for food recommendations by querying the foods to improve certain health outcomes. For example, we say like, could you recommend me a food to improve my deep sleep duration? This will trigger the agent to execute the retrieve food task to obtain the relevant foods and their nutrition contents and personal nutrition effects. The response demonstrates the food suggestions to improve the deep sleep and the explanation based on the estimated personal nutrition effects. The recommendations are explainable. By querying with "Please explain your recommendations," openCHA will display the rationale behind the food choices, focusing on their nutritional impact. But what if you're missing an ingredient or food? No worries. openCHA's interactivity comes into play. Remember that this isn't just a static food list. It's a conversation with your dietary needs. Ask a follow-up question like, I don't have the recommended foods. What are my alternatives? And openCHA adapts, offering alternative suggestions. By calling the tasks, openCHA not only delivers nutrition-oriented food recommendations but also enhances the user experience with personalization, explainability, and interactivity.
So this is just a demo of how you can communicate with external data, even external model, in this scenario, causal modeling pipeline, which actually had causal estimation and causal inference, and how you can really provide deep personalization, especially if you have enough data from that individual. So what has happened behind the scene, at least for the modeling part, and 3-year N of 1 data of this individual was used, the food logs, ordering, sleep, and the average, not the average, sorry, the individual treatment effect, the ITE, on the causal model that was extracted actually was performed. So if I even want to go deeper, we recently published a paper about also how to build personalized causal graphs. And the idea of this work is that we used it also for, again, food recommendations. The idea is that you have data, let's say, from sources like mHealth data or any other data you have. In this pipeline, causal discovery algorithms were used to build a big personal causal graph with a lot of nodes. But what happens when someone queries something, based on the query, for example, someone asks, okay, I want to prevent my glucose spikes. Based on that query, you know their goal. And when you know the goal, you know that which node in the graph is the actual goal or effect, if you will. And then the model actually traverses this graph back to build a subgraph that kind of leads to, to glucose or somehow causes or mediators or confounders to glucose. And then they also ranks them in terms of like their causal strengths, because these graphs are weighted and they have, meaning each edge, the effect size. And based on that, it retrieves the nutrients, like the nutrients. Like, for example, that scenario, it says vitamin E was one thing, foods rich in vitamin E help this person to have a better deep sleep quality. Now those nutrients are known, then again it can retrieve either through LLM or external source food database foods that kind of satisfy those nutrients, and it can even verify it through a simulation, even do counterfactual on the graph using other food candidates and try to then finally generate a response. And compare this with just simply using a pre-trained generative LLM, which can hallucinate a lot, and of course, usually they're population level models, but also population level can be wrong because all these analyses are ignored and we just simply trust the LLMs and the data it was trained on. Another demo, actually, yeah, we have time, so I don't want to play a video, but I can at least walk you through the paper. This one was, okay, whether when we provide this was actually for diabetes. I think this is the one that I covered, sorry, the demo 2. The other demo is about diabetes and how connecting our agents to an external source of knowledge, in this scenario, the NutritionX database, can make also the recommendations more accurate and grounded in knowledge. If you're familiar with NutritionX, it's the world's largest nutrition database with millions of grocery foods, or over 1 million of grocery foods, restaurant items, common food items in it. It's rapidly growing. So in this scenario, we connected or plan to integrate NutritionX to openCHA for our when we provide food recommendations for diabetes patients to be able to check their safety. So before even doing that, first we wanted to see whether LLMs, not even the agentic ones, just simple pre-trained LLMs, are safe enough or accurate enough to even start with. So that's when we collaborated with some industry partners, company iHealth in the Bay Area, to see whether LLMs, a few of them at that time, GPT-4, Claude and Gemini, can pass the nutrition, the registered dietitian exam, the standard one that every, of course, nutritionist would need to take. It has more than 1,000 questions. So these are the breakdown of questions: easy, moderate, difficult, and then some of them expert. So really like different type of categories of questions were kind of used in this. And we had in this study also domain experts, a few of them, who helped us also in this study. And it wasn't like we just simply use zero-shot question answering. We even tried to use more advanced type of prompting and chain of thought, for example, chain of thought with self-consistency, even a retrieval augmented prompting, to really try to do our best to use these pre-trained models to see whether they can pass the exam. But still no agentic solution, no integration with any external world. And the results were rather decent. We published that also. You can find it in this citation. We noticed that actually many models, especially GPT-4, they managed to pass the exam, the threshold, and the accuracy, for example, for GPT-4 was 87%. So rather decent, but you see, it's not 100% or 99 or something. Enough to pass the exam, but there's still a lot of errors or mistakes. So that's actually when we try to bring the NutritionX to the picture, try to run another experiment, which was GPT-4 versus GPT-4 plus NutritionX through openCHA. So very kind of fair, because we didn't change the language model, same language model, but this was more conservative because it would go and double check things to an external source of knowledge, to an API. So the idea was that you could ask questions, for example, about diabetes, for example, whether spinach and banana, or for example, this example, whether this food is safe for diabetes. This person is asking, I had this food, is it safe? Or this meal that I had? Well, GPT-4 misclassified certain components. For example, the amount of fat, GPT-4 said is not risky and it's okay, but even though it wasn't. Same with protein. This one example I'm showing you, because each of these would be checked from NutritionX. We and they're not generated, they're actual numbers retrieved from a database, the answers were much more, I would say, correct, and these were checked by domain experts. So showing just, you don't need to spend thousands or hundreds of thousands of dollars retraining models. You just need to build agents around them sometimes. Well, openCHA, of course, is open source. It's a platform that you can boot and bring, and have your own instance of it. But also we built a platform, like a service out of it, powered by openCHA, called Livi. And if you're interested in knowing more about it, it just tries to do whatever openCHA does without any coding, and is also available now. And we'll be happy to talk about it and chat about it. The idea is that when you use Livi, it has this dashboard that you can, for example, upload your knowledge. For instance, it can be all the clinical guidelines you have for a certain scenario, right? You have PDFs, that maybe 200 pages of PDF, rather than giving that to the patients, you can upload it here and it will use that as a source of knowledge. You can add, for example, certain guardrails. For example, say never prescribe or never recommend, or never diagnose, and so on. And you can also connect it, as I will show you a demo, connect it to external sources, for example, like Centralive or anything else, to trigger also just-in-time intervention based on data coming from that external source. All of them, these are already integrated. So let me show you a quick demo, and then I would have one or two more slides, and I think I will wrap up the presentation then. This is a demo about Livi, and let me play that as well.
Livi is a platform to build personalized AI agents. Let me show you how Livi allows you to quickly and easily build a custom agentic chatbot, cutting months of development time down to hours. Livi consists of a mobile app and a designer studio, simplifying the design and deployment of intelligent, evidence-based support chatbots. For example, imagine building a support chatbot for college students, managing stress and anxiety, with 3 goals. Monitor daily stress via Garmin's smartwatch, deliver personalized coping interventions upon stress spikes, and answer questions using pre-uploaded clinical resources, all within defined safety guardrails. Let's build it. First, roles and goals. We start by giving the agent a name and a clinical role. We call ours Stress Support Companion, an empathetic support assistant for anxiety and stress education. We then set 2 goals: help students better understand anxiety and stress, and deliver supportive psychoeducation using our approved materials.
And in this scenario, some off-the-shelf LLMs like GPT-4 was used, but you can use any other popular available LLM, or even bring your own LLM or use an open source LLM.
Next, guardrails. Then we define the boundaries. Livi's platform-level guardrails are always on, and we layer our own rules on top. For example, no diagnosing, no medical advice. Every response is checked against these before it reaches the students. Then, knowledge base. Here we upload our clinical materials. For this demo, we've added the Queen's University Managing Your Anxiety Workbook, a comprehensive CBT-based resource. Livi indexes it automatically. The agent now draws from this content in every response. Real-time data integration. The real power of Livi is in personalization. Here's where we connect Livi to the Centralive mobile health platform to ingest real-time data, like stress and sleep quality from a student's connected Garmin smartwatch.
Scenario 1, participant-initiated questions and answers. A student opens the app and asks, I have 4 essays due, I can't focus, and I just feel like I'm drowning. What can I do? Drawing from the workbook, the agent walks the student through a concrete prioritization strategy and a 5-count breathing exercise to calm their stress response.
What you're feeling is overwhelm, and it's very common. Start by writing down everything you need to do and organizing it by what's due first. Then, try a quick deep breathing exercise before you sit down. Breathe in for 5 counts, hold for 2, exhale for 5 to 7. This activates your body's natural calm response and helps you think more clearly.
Scenario 2. Trigger-based just-in-time intervention. When stress tracked by students' Garmin smartwatch crosses a defined threshold, Livi fires automatically. Drawing from the deep breathing and mindfulness grounding sections of the Queen's University workbook, the agent delivers an immediate, step-by-step calming intervention.
Hi, Alex. Feeling stressed? Try this quick fix. Try grounding. Notice 5 things you see, 4 things you hear, and 3 things you feel. This brings you back to the present. You've got this. One breath at a time.
So, yeah, let me finish.
Finally, monitoring and data access. Your team has full visibility in the admin dashboard. Every conversation, every trigger, every Q&A exchange, giving you the structured data you need to measure engagement and program impact.
Yeah, of course, the platform is HIPAA compliant, so needs to also a private instance of it, usually load for each group, so that they can make sure it's on premise, and of course the consent from users. So if you're going for grants, we're of course always open for collaborations, and would like to talk to you also about possibilities to kind of partner. So I think I have slides on also the validations and so on, and evaluations, but for the sake of time, I'll just maybe stop here, because I think for Q&A it might be important. But maybe just I can just quickly say that this one slide, because this is an important part. We often we know the power of LLMs and agents, but there are also a lot of considerations, especially when it comes to evaluation. And this is one of the work that we started also our center on how to systematically build evaluation frameworks for understanding and evaluating healthcare, CHAs, or conversational health agents. Usually, I think I was promised to wrap up by that, so maybe I can just stop here. And if as part of Q&A we need it, I can maybe use these slides to answer some questions if there are any questions about evaluation. But thank you so much, everyone, for your time. And I'm here. These are links to openCHA or other places. So let me know if you have any questions.
Well, Amir, thank you so much. We have turned on the ability to unmute yourself and to turn on your camera if you have any questions. And I do see one question here in the chat. That very interesting and innovative work. How do you integrate existing and published research literature with the insights derived from the N-of-1 approach for personalization? Additionally, do you address situations where an individual's data patterns are not consistent with findings from the existing literature?
That's a great question. Something I wanted to mention that what we do in that paper, it talks about, one possibility is that the best case scenario, you have a lot of very rich N-of-1 data from one individual that you have seen enough scenarios, like good nights and bad nights, like sleep quality was, right? So you've had enough variation in the data. That is usually very ideal, but very hard to get. That's why we bring other benefits of causal modeling and looking at ITE, like individual treatment effect. ITE, even though you're trying to just show that treatment effect on this individual, you also use the data from others, like a population level or other kind of data that is available out there, or even if you have a cohort. And that happens like through matching, like finding similar people like you. And that's oftentimes in many recommender systems, they use that to kind of also try to do matching. So we use ITE to bring that, to leverage other people's data as well as that person's individual data. So especially if you're looking at counterfactual, like what if, because if you have even very rich N-of-1, there are certain things that that person hasn't done. So you can't answer those type of questions. But that type of analysis will help a lot to also bring that, the do operator in causal modeling, when you can also look at counterfactuals or the third ladder. The second question was on when something conflicts the clinical knowledge. That's an interesting part. I don't have a very, how to say, great answer to that. I think that should be part of the guardrails, because depending on the question, the case by case, it can really vary whether you want to give some room, because sometimes there's even not enough knowledge on that certain thing that happens, so unique combination of many things that you don't even know if the knowledge will apply. But sometimes the knowledge is really kind of strict in the sense that you may not want to even recommend and go beyond those boundaries. I think that's the part that providing guardrails and bringing that and testing those scenarios as part of the evaluation becomes important, because certain contradictions you may not want to even due to safety reasons or other things, even let the LLM provide that personalized answer because you're not sure if it's safe or not. But sometimes it's just a very, how to say, wellness-related things that may not be really kind of, how to say, safety critical, but can help the person to perhaps explore different options about their lifestyle, because each of us are unique, and at the end of the day, it doesn't hurt to let them try it, and then through optimizations and other ways to understand whether that something worked or didn't work for that person. I hope I answered it, but there is no bulletproof answer for that question.
Thank you so much, Amir. Does anyone else have any questions? You can either raise your hand or just go ahead and come off of mute.
I've got one. If I can, I guess I can't turn your camera on. Okay. Can you hear me?
Yes.
Hi. Thanks. This very interesting what you're trying to do. I'm curious about openCHA, because it sounds like you're running it and then there's essentially a loop going on, right? Of this reasoning loop. Have you done anything where you look over time to see if you're getting essentially consistent behavior for a longer period of time, and how do you achieve that so that, at one point in time it's not giving kind of one kind of advice, and then a little bit later in time it might be giving different advice that might be not consistent, sort of assuming whatever's going on in the real world, obviously that's changing.
That's absolutely right. There are certain things that you can do. One thing that as part of our evaluation framework we try to look at also the consistency, or how to say, the acceptance between responses when you ask the same question multiple times, to see whether like the generated answers actually are more or less in agreement, and also if sometimes, for example, disambiguation is needed and so on. So as we oftentimes try to kind of test those as part of the evaluation framework. That's why the evaluation framework really needs to reiterate and so on. The other thing is that how we can bring this multi-turn evaluation or trajectory to evaluation, which is something these days still not how to say, commonly done, because still most of the evaluations of chatbots are single turn. There's a question, there's an answer, and so on. But certain things emerge through a conversation, especially, let's say, mental health, right? If during a session or 1 hour or a few minutes of a discussion, certain things will emerge. So that's why the notion of multi-turn evaluation needs to come into the picture, because when you're asking, and you want to make sure, for example, the agent is consistent over time, that needs to be evaluated. And also, then you can loop back that kind of what you learn to further refine the agent. So not only that evaluation can be used for inference, but also can be used to kind of optimize the agent. since there are a lot of ways to do that, but you can also put some constraints, like for the agent, even though it can there's a loop, but you can also give it some structure, saying that in this situation, these are the things that I would like to collect. So, in other words, if you have used platforms like Claude, they have this notion of skills, and they capture skills from each individual, right? For example, like skills for UI UX is on a skill. Like imagine you have now capture skills from a therapist, and those skills can also guide the agent in real world how to do things, because you don't want it to get stuck, right? And so there are a lot of ways to make them more and more, I would say, predictable and robust, and hopefully more grounded.
Yeah, thanks.
I don't know if I answered your question or not.
Yeah, I have a follow-up actually. Is most of your testing a simulation at this point based on data you've already collected, or are you also deploying these things live with people interacting with them in real time and evaluating them that way?
I would say both. Of course, we start by building kind of a I mean, I don't call it simulations, but yeah, building like using benchmarks that were kind of curated and designed by domain experts, but also testing them in real time. And that's actually the part that I wanted to, for example, share with you, maybe in my slides again. In fact, for example, one case that we did, for instance, this was also openCHA. We wanted to look at the safety of chatbots, right? And this is in the evaluation framework that we designed for safety of mental health chatbots. So actually, we collaborated with a few folks that were domain experts, like clinical psychologists. We came up, for example, with 100 questions, benchmark questions for different situations. For example, situation for crisis, situation for suicidal ideation, and so on. Also with design rubrics, for instance, adherence to guidelines, or if the response is actually consistent with the critical situation, and so on. And used both and got help both from domain experts and LLMs as judge, to see whether, for example, these models do a great job, or how confident they are or correct they are in their evaluations. So that's one way that we do. In this scenario, the ground truth or the safety of the answers were about 7, but unfortunately most of the LLMs over kind of estimated the safety, or they are too optimistic, even though not all the answers were safe. When we brought agentic approach, it got closer to the you see ground truth, but still it wasn't like ideal. So that's just one way that you can do it. So the LLM as judge are used a lot, and also building agentic frameworks to simulate. But we have also started using, for example, one study with college students, stress management. We have deployed the platform and looking at it. But yeah, I don't know if that answered the question.
Yeah, thank you.
Sure.
Thank you so much, Amir. I think we're coming up on the top of the hour, so we'll go ahead and wrap this up for today. But this, and as all other M.Dot Center webinars, will be available on the mHealth Hub. And we just want to thank you, Amir, so much for joining us and presenting your work today. Thanks, everyone, for joining.
Thank you for having me. Thank you, everyone.